Hey guys. Alright, one thing that I'm going to do in the course is that I'm going to work homework problems from your chapter. I won't work every one of them that you have, but I'll work the ones that you need probably need a little bit of extra help with and be able to follow it. Okay, and how I choose to work them isn't the only way that they can be worked, but the way that I choose to work them, I work them in a structured manner, organized, and I repeat the same method each time. Okay, so what we're going to start with is the problem from chapter 2. And I have the problem up here, as you can tell from chapter 2. This is going to be the only problem that I work from chapter 2, but in it I'm going to incorporate other concepts that are within the chapter. Alright, problems in chapter 1, I'm not working any homework problems for those. Those are primarily just definitions and concepts. That's what you have to read, memorize, and be able to apply. Chapter 2, a little bit more math, but then once we get into 3, especially 4, 5, 6, 7, and 8, I'll be working more problems. So for this one, first thing it says is the lower class limits. I need to identify them. With a lower class limit, each one of the things are broken down into what you can call classes. Okay? Classes, and that's the key concept. And for this, what it will be is the first number, or the number on the left of each class. And if you look at the problem, these are broken down into classes. The first class ranges from 25 to 29. The next class, and so forth and so on, until they have all the data that's in there. Okay? All the ages that they have in their survey or their data collection. So, those are all my classes. The number on the left of each one of those classes, or the first number in that class, is my lower class limit. It's the lower of all those numbers in that class. So that's my lower class limit. And then all you need to do is to type those in. One thing to be sure that you're paying attention to whenever you're working these problems is that what's typed in the blue, how to input your answer. That's something that can get me, and you sit there and you battle with, and you have the right answer, except you don't have an extra decimal point, or you put in too many decimal points, or it says make it a fraction. So pay attention to that. So this one here says ascending order, so going from smaller to larger. And let's see, let's check our answer. Excellent. Okay, the next one is the upper class limit. Well, the upper class limit is the same as everything else that's worded here, except it is the number on the right of each class. It is the greatest number within those classes. So, like bookends. This is the beginning, this is the end of that class. It's grouping each class. Another thing that I do is I try to look at my answer before I put it in. I can be notorious about being a little dyslexic with my numbers and flipping them, so I try to take my time. Okay, identify the class width. Class width is simply the difference. What does difference mean when we're talking about math? Yeah, subtraction. So you're going to subtract. Okay? And what you're going to subtract are two consecutive lower class limits. Okay, all of our classes are going to be the same size. Otherwise, we're skewing our data. We can't have one that only contains 2 ages and then the others each contain 6. Okay, the likelihood is that the one that just has 2 ages, you have fewer people. So all of our classes are distributed evenly. All right. So for this one, the difference between two consecutive lower classes. So I'll just pick the first two. So with that, I'm going to turn around, and this is going to be 25 minus 30, or so we don't get a negative number, 30 minus 25, which equals 5. This is my class width. Now, if you want to pause the video and just start looking at all your numbers through there, everything's matched up by 5. There's 5 values in each class. So 25, 26, 27, 28, 29. There's 5 values there. There's 5 that separate the lower class limits from each other, and there's 5 that separate the upper class limits. So once you find the class width, it really helps for you to be able to set everything else up. Class midpoints. Well, keyword in there is midpoint. Okay, so really what you're going to do is you're going to take the sum and divide by 2. And what you're looking for are the values in the middle of each class. So for that one, what I have to do is I have to do it with each one. So I need to say 25 plus 29 divided by 2. And then I need to say 30 plus 34 divided by 2. 35 plus 39 divided by 2. And I have to do that for each and every one of them. Now, luckily, our numbers here are easy, because I can look at this and be able to see what that midpoint is for each one. But what I caution you with that, it's always good to do the mental math. Always do it. But check your work before. Don't just go off your mental math. Sometimes we just have bad days and things are sketchy for us. So I look at this and I say, okay, 25 plus 29 divided by 2, 27. It's actually the midpoint between 25 and 29. So, and I'll write these in red. 27. See, I can look at each one of these and say, okay, well, I bet you that's 32. Let me check it. 30 plus 34 divided by 2. 32. 37 and 42, 47 and 52 and 57. And if you look in between each one of these, the class midpoint is going to be 5 apart from each other. So honestly, if your class or your class width, once you find that, once you find your first class midpoint, it's 5 separating all of those. It's the class width is throughout all of your numbers. So, sake of time, let's go ahead and just enter in some values here. So we'll say 27 and 32, 37, 42, 47, and 52, and 57. And let's check. Yay. And then our class boundaries. Well, your class boundaries are the numbers used to separate the classes. Okay? It is the midpoint between those numbers. So, with talking about that, our class boundaries is, I'll write down a couple of these. So I have 25 to 29, 30 to 34, and then 35 to 39. What I'm looking at is I'm looking at what is the boundary that separates these two numbers. And what you're more or less doing is you're finding the midpoint between those two numbers. What you're finding is 29 plus 30 divided by 2. Again, we have some easy math for us. 29.5. But one thing that you must make sure of is that you have to include this one also, and then this one. You got to have class boundary established here and here. So once you find the pattern for it, like 0.5 separating each one of them, it'll be a 0.5 there and a 0.5 there. So I will start with the very first one, and that will be 24.5. Now 25.5, that's within the class, and then 29.5. And just from the two that I entered, what is the difference between the two? It is the class width. So the next one's going to be, whoops, so that's some of the stuff I do, 34.5. And the next one will be what? 39.5. And the next, 44.5. And the next, you see that I'm more or less just adding 0.5 to all of them except for the very first one. I had to subtract 0.5. Excellent. Now identify the number of individuals included in the summary. And what you need to do is you need to add up all your frequencies. And I'm going to start using this term N. N is your sample space. N is the total number of whatever data you have and that you're using. And you'll see that once we get into the problems, the more statistical problems. N is always your sample space or the number that you have. What I need to do is I need to add all of those up. So let's take a look at that. I have 31 plus 35 plus 16 plus 4 plus 6 plus 1 plus 2. So 31, 35, 16, 4, 6, 1, and 2. Total of 95 individuals. N is 95 for this one. N equals 95. Yay. Okay, so we're going to leave it right there because what I want to build upon is relative frequency in our distributions. To find the relative frequency, you have to take each frequency that you have. Let me make us an area here. You have to take each frequency. So for instance, the frequency for the first class, 25 to 29, that frequency was 31. Well, to find the relative frequency, whoops, I simply say 31 divided by 95. And this is where it's important to know how many decimal points you have for entering in your answer. 31 divided by 95, and I'll write it out to 4, 3263, and then I can convert that to a percent, 32.63%. Okay, now the reason that relative frequencies are good to use is because sometimes it helps us to be able to conceptualize our numbers. I could have some just crazy huge numbers. Say if I did this massive study over years, and if I just say in the first class, there's 1,343,000, and I can't conceptualize like for myself exceptionally small or exceptionally big numbers. But if there's a percent placed on them, then I can understand that. For instance, like 2 cups is 16 ounces, but if I say that I drank 10 ounces, I don't really know. I know that's more than a cup, but if I turn around and said I drank 60%, in my mind, I can see 60%. I understand that better. That's why relative frequencies work very well, to be able to present your data so people can see it and be able to understand. That's all you have to do. And your relative frequency and your frequency distributions, if you take those and convert them to a histogram, they're the exact same histogram. Relative frequency and frequency distributions will give you the exact same histogram. Okay, so let's look at this, what we have, and talk about distribution. And just think about the word. Whenever you distribute something, you pass it out. What we're looking at here is how's our data passed out amongst what we have? How does it look? How does it appear? And you have normal distribution, where you have just a basic bell curve. And it is symmetric. Okay? Then you have uniform distribution, and it's more or less a straight line across. And then you have distribution that's skewed right. And think of your right foot. You have a big toe, and then your other toes get smaller. And then skewed left is like your left foot. Okay? Small toes gets bigger. So I can look at my data and I can see that the very first class in there has a lot of data. In my next class, it has even more. And then it all starts to fall down and drop. So what I'm looking at, and this is just a rough sketch of the data from there, is I'm looking at something that starts off high and then drops. My data is skewed right. Starts high and drops. It's not normal. Normal starts low, increases, hits a peak, and begins to decrease. Uniform is to where all my data would be about the same. Every one of them would be around 30. Skewed left, I'd have more data in my higher age groups, my further, my class, my classes that are down here. I'd have more data in it. All right. So that is basic information for what you need to have for Chapter 2. On subsequent videos, what I will do is it'll just be one problem that I work in there and I'll explain concepts with it. So you'll have multiple videos for your other chapters. Please watch your videos that are in my math lab. Please structure your work and critically think about what you're doing. Write everything out, okay? And think about what you're doing. Reason through. Good luck with your homework.